So as I said before, converting a rectangular point to the polar coordinate system does take a little bit more energy, I guess you want to say, a little bit more thought, a little bit more concentration. So we're going to take a look at that. So remember the formulas we derived at the very beginning. We have either x squared plus y squared equals r squared. That is your Pythagorean theorem. And of course, this one is just r being simplified, or r being solved for. So when we're finding r and theta, we're going to assume that we want r to be positive just because that is the natural tendency. We think of r as a distance. So we're going to say that r is positive. And remember this other one, tangent theta equals y over x. It is a little bit of an obscure formula, but it really is useful. So let's take a look. So we have the rectangular point 2 comma 2 root 3, and I always plot these points because I want to get a sense for what I'm looking at here. And this is where 2 comma 2 root 3 lives, okay? And boy, that got really thick. So I'm just going to dial that down to 3. Okay, so we definitely know that theta is between 0 and 90, which means we're in the safe zone as far as finding the angle. If we use the inverse trig functions on the calculator, we're always going to get the same angle. And then finding r, though, I mean, that's not really a thing because we know that r squared is x squared plus y squared. So I'm just going to set that up first. This is probably always going to be the easiest thing to do. So r squared is 2 squared plus 2 root 3 squared. So r squared is 4 plus, well, let's see, 2 squared is 4. Root 3 squared is 3. So it looks like r squared is 4 plus 12, which is 16, which means r is 4. So if I have my r theta, I know that r is 4. So it's 4 units away from the origin. Great. What's the angle? Well, I know that tangent of theta is going to be y over x. So I have tangent of theta is going to be 2 root 3 over 2, which means tangent of theta is the square root of 3, and that is one of our special ratios. So we know that that corresponds to a radian measure of pi over 3, or 60 degrees if you're talking about degrees. I'm going to leave it in degrees because we have a better sense of what that is. So 4 comma 60 degrees, or if you're in a radian mood, 4 comma pi over 3. So there we have that. Okay, now let's look at a different point because quadrant is an issue. So -4, -4. Well, we know that that is 4 to the left, 4 down. So the question is, what is this theta and what is this r? Well, again, r squared is still going to be x squared plus y squared. Well, that means r squared is 16 plus 16 is 32, which means r is equal to the square root of 32, which I'm going to write in simplest form as 4 times the square root of 2. Great, so there's r. Now we know tangent of theta is y over x, which means tangent of theta is 1. Now we know that corresponds to a magical angle of 45 degrees. But that's a first quadrant angle, so that my angle can't be 45. But the thing to keep in mind is that this reference angle right here is 45, which means what is the actual angle? It's 180 plus 45, which is 225. So the answer is 4 root 2 comma 225 degrees, if you want to leave it in degrees. And using radians, that would be 5 pi over 4. So there is converting. So there again, your key strategy is finding r, pretty straightforward. Make sure the theta is in the correct quadrant because that could get us every time. And basically, if you get an angle theta that is not in the correct quadrant, you can usually just add either 180 or 360 to it and you'll get to the correct quadrant. So keep looking at that and hopefully that makes sense. Thanks for watching and watch out for more videos.